Hello, my name is Gursevak Singh. My student ID is 203211702. I am a student of MSc Data Science. Today I would like to present on a topic, a framework based analysis of security risks and mitigation strategies in large language models. This is the topic of my dissertation. This dissertation is a secondary. I have used secondary qualitative research method in this study, and I basically focused on OWASP LLM top 10 model and NIST AI RMF model. So moving forward, this is the overview of my presentation. First of all, I would like to tell about the background and problem why LLM security matters, research aim and questions. I have developed 4 focused research questions, then literature review, key risks identified, and then methodology. A secondary qualitative design I have used in this research, and then analysis and findings, in which I tried to map OWASP and NIST model, and then mitigation strategies and conclusion and recommendations. First of all, if we talk about background and problem statement, first thing we need to know about why LLMs are different. LLMs are large language models. Now, chatbots, RAG systems, agents, enterprise tools, and APIs are all powered by LLM models. LLM models are like ChatGPT, uh, ChatGPT, Claude, and these models basically interact. And generative artificial intelligence, these are all phases of generative artificial intelligence. Large natural language has become the control surface, unlike traditional software. User prompts, document retrievals, and external material can change behavior. This is all about uh, importance of LLMs. We need to know about LLM integration with APIs, plugins, databases, increasing the attack surface. Security failures may expose data, execute unsafe code, or trigger actions. Now, the problem statement is that risk of LLM are difficult to categorize, include traditional and model specific risks. Prompt injection, data poisoning, excessive agency, and misuse interact in practice. Academic literature, OWASP, and NIST guidance are not yet fully integrated. Rapid deployment outspaces security framework maturity. Organizations need a structured, combined technical and governance view. This is a problem statement. And if we talk about research aim and questions, the aim is basically to critically examine the security vulnerabilities and mitigation measures of large language model applications using a framework based secondary research design with particular reference to OWASP top 10 and NIST AI RMF. Though research questions, there are basically 4 research questions in this dissertation. First, what are the security risks mentioned in recent papers on the large language model applications? How research question 2 is how can the key research security risk in LLM applications be classified? Research question 3 is how useful are the OWASP NIST frameworks for classifying and assessing the security risks in LLM applications? Research question 4 is how can we mitigate the risks to measure development, deployment, and governance of LLM applications? So, literature review. Literature review highlights key security risks. First of all is prompt injection, direct and indirect manipulate model via adversarial input or retrieval content. Second is sensitive information disclosure. Third, risk security risk is insecure output handling. Fourth risk is data poisoning and retrieval manipulation. Fifth risk, which literature has highlighted, excessive agency agents. LLM agents with broad tool access perform unsafe autonomous actions, model misuse, and dual use risk. These are risks identified. Methodology, research design is secondary qualitative, no primary data testing. has been conducted. Such strategies Google Scholar, IEE, ACM, Science Direct, Springer, etc. have been used. Third is data screening. Three is stage screening, title, full text, framework fit. And fourth is data analysis method deductive, thematic OWASP and NIST mapping. Inclusion criteria basically 2015 to 26 those studies have been used. Priority is given to 2023 to 2026 peer reviewed journals, conference papers, and so WASP LLM Top 10 Framework Analysis. WASP Top 10 for large language model applications. Main technical framework. It guides about prompt injection, core risk, natural language data, and guidance. There is no full defense. Risk at the application level. Sensitive information disclosure, insecure output handling, data poisoning, excessive agency, supply chain, and third party. Critical finding of this framework is that OWASP translates research into practical developer categories. Prompt injection has no complete mitigation, control, reduce, but cannot eliminate risk. Insecure output handling proves LLM security is a software integration problem, not only a model problem. RAG specific data integrity risks make source validation a source security control. Framework listing not equal to risk control. Governance needed alongside classification. These are basically this is critical findings of the WASP LLM top model. NIST AIRMF governance lens. Govern, mapping, measure, and manage. This is a governance framework. Governance lens NIST established responsibilities for accountability, ownership, risk management, oversight of LLM. It maps, it develops users, determines users, information sources, etc. It also measures, test, red team, monitor prompts, outputs retrieval. It is basically apply, then it apply controls, access control, output filtering, human oversight, and so on and so forth. WASP, if we draw a comparative analysis, which basically deals with the research question 3, risk, three categories have been identified. Risk are issue, OWASP contribution, and NIST contribution. Prompt injection, if it is a risk which we have identified through literature review, in literature review prompt injection, then OWASP contribution core technical category identifies attack patterns. NIST contribution requires testing, monitoring, and risk management. Info disclosure classifies as direct application risk, governance, privacy, accountability, and life cycle. Insecure outputs, data, similarly data poisoning, excessive agency, misuse or dual use, supply chain, etc. Mitigation strategies, layered control. Mitigation strategies, if we talk about prompt injection, then input filtering, prompt hardening, retrieval filtering, output monitoring, sensitive information disclosure, access control, data deminimization, masking, and reduction log control. In secure output handling, data poisoning, excessive agency, and all mitigation strategies are briefly mentioned in here. Conclusion findings research question 1 has been literature outlines 7 high order risks, and research question 2, research question 3, and research question 4 all are completely answered in this research. So basically all questions have been answered in this. And then conclusion chapter. Then recommendation for secure LLM development. First of all, combine OWASP and NIST frameworks. Then least privilege must be given, shall not be given to anyone. Research question 3. Recommendation 3 is validate all LLM outputs. Recommendation 4 is secure RAG pipelines. Recommendation 5 is reduce data exposure. Recommendation 6, test thoroughly everything, facilitate auditability. Audits must be done after a specific period. Check regularly. LLM security is changing fast. Not a one-time deployment need, but a continuous control shall be made. Thank you very much.